Hello, my name is Luis Villar, and we're going to be showing you the STX Transaction Server. We're going to be using the STX Transaction Server in order to call a URL with parameters in order to send a short message, an SMS short message. We will be using the diaphan server, SMS server, to send the message. The diaphan server gives me this URL where I could send the message. I have the parameters that it needs for it to send the message. And if I invoke the command, it returns to me in text mode, OK, colon, and the ID of the message. That beep you heard was the message actually arriving on my phone. Here we're going to take a look at the URL that was used to send the message. Basically, you have the URL itself, then you have the command, which is send message, username, password, the to number that's going to receive the message itself, the message type, and the gateway. This is basically so I could send it through one modem in the modem pool. At this time, I'm going to show you the STX running. It runs under Apache Tomcat, so we'll go to Manager App, and we'll choose our app right here, which is the STX. And this is what the STX looks like. It's a web page where you can see configuration information, log information. This is where we're gonna be spending most of our time. And then we have a test area where we can put an XML string here and send it to process, and the STX will answer us back. And here is our server statuses and our channels. As I click on the shapes, if I click on the star shape, I can see the input and it'll show me the output at the other end on the end shape. When I click on the task, it'll show me the input of the task and the output of the task itself. The task is where I'm executing, going to the URL, and here is the answer that I get back from the URL. The decision, here I'm checking to see if the process finished okay, which it did. And then basically here on my transformation, I'm transforming this string, which is OK colon and the code, into a XML string which has a status tag and an answer tag, and each one of them has the discrete information. So I translated from having this in a single string to having it in an XML with each value having its own tag. This is the designer. Here's where we design processes. This is the very simple process we just explained before that we watched live on the STX. We're going to go through each one of the shapes and how they were configured. The first shape we're going to look at is the start shape. The start shape is this little blue ball here, and we're going to double click on it, and we're going to see the information that we can program into it. Basically, what we're going to program here is an XML scheme of what it is, the XML that is expected to come into the process. Basically, the name of the process, enviar mensaje, it adds input to the end of it, and that becomes a root tag. And then we have two child tags, which are to and message. This is actually clear if we see it from the log of the STX that's running. And here for this transaction, if we click on the blue button, we can see enviar message input, and then we have our to and our message. This STX ref is an internal reference number that the STX used for its own purposes. But we have our root tag, enviar mensaje input, and then we close at the end. We have our to number, which is going to receive the message, and the message itself. The next shape in the process is the task. Here the task is where we're actually going to go to the URL for the diaphan server and pass it its parameters so that it can actually send the message. The diaphan server will answer back to the task, and the task will capture the answer. Basically, when we double click here, our first tab is our entry. This is what we expect to come in, and here's the information that we saw with the URL at the beginning when I showed you how to send a message using the diaphan server. Basically, from the URL, we are defining the command, the send message, the username, the password, the to number, the message itself, the type, message type, and the gateway. So here we have the name enviar SMS texto, which basically is the name of the task, and this will become the root node of the XML. And inside that root node, we have the send message command, and here are the parameters of the URL. And this is how we define this process. Now we have our answer. Basically, it's empty because our answer is just a single text line. If I were to receive an XML data, I would define that XML data that I'm expecting to receive. But since this particular process, I'm going to show here in the log, if I click on the task, here's my information already set to be sent to the diaphan server to send this message. And then all I have is my root tag and the information that he answered me in text. That's why there's no definition of any fields inside the text. So I have my OK, 2 dots, and global ID number that is given to this text message by the diaphan, so that the calling system can make reference to it to see if the message was sent, if it was received, and what happened to it. The next tab is the exception tab. Here I'm going to define how I'm going to capture exceptions from the process I'm calling. Here basically the system I'm calling will return on the first element of the XML string the exception message, and so I can capture that. And then there's a decision here. This decision here is based on results. So basically this decision is simply asking if this process ended well. If it didn't, it will take whatever message the call system sent back as an exception and put it on the first element. And then what we'll do is we'll pass that to our exception ending. And finally, our last tab is the properties. Every task has to have a name, and here's where we give it the name. Enviar SMS texto in Spanish, send SMS text. And every task has to have a server associated to it. Now, here we have several servers we have configured. I'm using the modem pool server, and I will explain a little later how to configure this, how this server is configured. It also has, in this case, it doesn't have a loop, a cycle, but you can iterate through a process based on conditions, based on information you're receiving, but this is a little more advanced, and we'll look at this in another video. Again, the next shape after our task is this decision. This decision is okay, basically. It's basically asking if this process ran okay, and it's based on results, which basically means if the process ended well, it'll go through the true path. If it had an error for some reason or an exception and the process could not execute well, then it will go through the no path into our exception ending. Decisions can also be based on expressions. In this particular process, it is not needed, but in many processes, it is. Actually, both are needed. Once you know that it's okay, then you need to analyze information that came in the answer. And based on that information, you can write an expression, which basically there's a little, here I can find all the variables I have. And here I can pick a field and I can say if the phone number is equal to so now it will take this expression and evaluate this for true and false, and it'll go accordingly to the true path or the false path based on the expression. This is very powerful features. Besides just checking out variables, you can compare against tables. There's functions you could use also, and operators. The next step is the transformation, the XSLT transformation. These are very powerful. Basically, here's where I get the string that comes from the answer from the task, and basically it's a string with two pieces of information with a colon in between them, and I need to separate them and create an XML output that has each of the values in its separate XML tag. I'm going to double click on the transformation shape, and basically this is the XSL code that basically does the task for me of grabbing the string and converting it into an XML with two tags. I'm going to show this in stylus so I can explain it better. Here I have my transformation in XSL, and basically what I'm doing here is I'm matching the template variables, which the STX has all the information that the process has generated inside variables. So as the process moves along, you have access to all this information. At this time, when the transformation is defined inside the process, I have access to the answer to my process, which is this one right here, which is the OK with the colon and the ID for the message it's supposed to send. Over here, I match it to variables, and then I create my to respuesta output state, and then I go select the substring before, then I select the tag that has the information, and the colon, which is what I'm looking for. So the information that's before the colon will be displayed here in state, and substring after the colon on the same variable will be shown here, which is the ID. And when I run this at the bottom here, this is my output, exactly what I wanted. I wanted a single XML, which the information separated. I went from a string that had OK colon and the code to an XML that has both informations in a separate tag. Finally, we're going to get to our successful end shape, the green ball here. When I double click on it, I define what is it, the XML that I wanted to give out. And here we have enviar mensaje output, which is the name of the process with the output appended to the end of it. And basically, here is the same schema of the XML that I converted transformed in my transformation. So basically, I'm putting it here so I'm able to pass it from tu respuesta into my successful output box. So basically, this will be here. Enviar mensaje output will be my root, and I should have estado and respuesta in. How do I make the assignment? On the line here, arrow that links them, I have here my answer, my transformation. So I can just put state, or message and message. Since they are the same shape, they're the same XML format, I could actually grab it from the root here and put it to the root here, and it will assign estado and respuesta also, and that'll work just as well. Since there's only two elements here, it's not too much trouble to assign one by one, but there's some real complicated processes where they have really nested and a lot of information. We're doing a deep assignment where you can just grab the root and assign it to another XML that has exactly the same shape or the same format, and that's a lot easier and less error prone. Now that we've seen how the process is created or how it's defined, we're going to take a look, go back here to the task properties and see how this server modem pool is configured. We close the process defining window, and we go here to the servers, and here's modem pool. So we'll click on modem pool and we can take a look at this. The server's definition here, we give it a name, and there's what type of server. This server in particular is a web. So it's a web page that I'm going to invoke, and the STX will process it. There are lots of different servers. Everything from database, Oracle, SQL server, where I can execute stored procedures, to web services, to AES400, terminals, SIM21. There's AES400, even DBF files and access files. There are a lot of servers, and each server has its own configuration, but creating processes is all the same as explained earlier in the picture, in the video. Here, what the important thing here with the web, here's the URL. We get the URL up to the HTTP, and then inside the task, we put that the command was message, send message, and the parameters that it needed are also defined in the task. And here are several configurations. We could tell it to have a verbose log. XML characters is what it's going to use for in and outs. The timeout and the port, it's in port 80. And URL format could be normal or it could be JSON. And this is all you need to configure this. And if I put this on any other task, I can execute any other command that the Diaphan server has to offer. Now that we have seen how the process is defined and created, let's see how it could be invoked. Here is our original URL, but this URL is actually going directly to the Diaphan server. So when I hit the refresh, the ID will change, and in a second you'll hear the message arriving at my phone. Here, I can invoke the STX by sending the URL of the STX. The 9102 is the port where the Tomcat is running, and the STX core underscore USSD is where my STX is running. I'm going to send my process name, enviar mensaje, which only has two parameters, the to number and the message itself, and that's it. So if I send this guy out, here I get my answer, which was at the end of my successful, there's the message, at the end of the successful green ball, which was a successful ending. See, this one was directly to the diaphan where it answered the OK, 2 dots, and the ID of the message. And here is using the STX. I invoked it as a URL. And here's the answer that I got back from that. I could also, from the STX, if I put STX capital, WS lowercase, I hit enter. Here I have a web service. I could actually invoke this as a web service. This is the wisdom. And last but not least, we can also invoke it as a socket. Here I have my IP, my port. I'm going to create a TCP connection, connect it to the server. I'm going to send my XML, enviar mensaje, the to number, and the message, and then close it. I'm going to send, and here's my answer. Over here is what I sent, but from, there's the message. Over here, if we pretty this up a little, here is my XML. This is the XML that, oops, there we go. And we bring this one back up here. And we indent state and answer. And we get this, the opening tag down here. And here we have our answer, an XML with state, OK, and the global identifier of the message in XML format. And this is basically what my process does. Basically, I don't have to send all the parameters of the diaphan because they're already inside the process. And the answer, instead of getting the single string with the colon in the middle with the two pieces of information on either side, I get them each in an XML, each of them in their own tag. Some of you may be wondering where I got the socket number, the port number for the socket. I got that, if we go here to our servers and channels, from my channel, this one right here on top. It is channel 12023. That's the port number. So this IP with this port number is the socket version of communicating to the STX. So we show the STX, the process, how it's defined, and how to access it via a URL, via web service, and via socket. Hopefully, after this explanation, you have a better idea of how the STX works. Good thing about it is, as you see, there's not a lot of programming into it. Basically more knowing the process, and you really have to have a good knowledge of XML, XSL transformations. The more you know, the more powerful the tool becomes. And basically BPMN is a good start also because it explains the flow and the shapes that we're using here. And just finally, so that I can show you I'm going to show you some other processes that are a little more complicated than this, so you get an idea of how deep you can get into with the STX. Here we have this process that does a bank transaction and basically has to take a lot of decisions, and it has two options to go to two different services depending on what platform the calling client is from. I'll show how this looks in the log on a live production system. Here we have an STX log with a lot of activity and with the process that I just showed you on the slide before. And we can notice that even though there's a lot of things going on, they process under half a second, most of them. We'll go to one of them, and then here we can see the beginning and the end input and output. But as you get into these sub-process, you can open them and see what the sub-process does. And when you get to a task, it tells you how many seconds it took to execute that task. This is really good in case the process takes too long. You know exactly where in the process it's a problem, where it's taking too long. So all these decisions and executions are going on. Some transformations also that are needed for the process until we get to the end. But this is what a process well orchestrated looks like. And basically you have the log here, and using XPath you can filter out and find processes when you need to diagnose or look at a particular transaction. This for now is the end of this presentation, and I hope it's been very helpful to you. Thank you very much for listening.